Hey everybody, welcome. This is the first BIOSPHERE Rule Materials Parsimony, and this is the first video in our series. So, what is materials parsimony? Well, quite simply, materials parsimony is about simplification. We can describe or define materials parsimony as minimizing the types of materials used in products, right? Now, I want to be careful here because I'm not talking about minimizing the amounts of materials. Minimizing the amounts of materials is a different sustainability strategy. Sometimes it's called eco-efficiency, sometimes it's called dematerialization, sometimes it's called lightweighting. We are not talking about that. We're not talking about volumes, we're talking about types of materials, all right? That's an important distinction to pay attention to. And we'll see why minimizing the types of materials is so important as a foundational starting point for the BIOSPHERE rules, right? And understanding the power of simplicity is something that humans, especially deep thinkers way back through the ages, have really well understood. I mean, go back over 2,000 years and Aristotle is saying the more perfect a nature is, the fewer means it requires for its operation, right? Understanding the simplicity is actually far more efficient in terms of operation. Jump ahead a couple of thousand years, or a few millennium, and we have Leonardo da Vinci saying simplicity is the ultimate sophistication. And then finally in my century, maybe yours, depending on when you were born, the architect Ludwig Mies van der Rohe actually said what all these other sages were saying: less is more, all right? So this is really important. We've understood this for a very long time as human beings, that less complex is actually far more sophisticated and actually far more effective. So we've discovered this, we've learned this, we kind of lost it in the 20th century, we'll see, but the greatest, the master simplifier of all is the Earth's biosphere. So if you saw the previous videos, you know that our founding principle here is the biosphere is the only model of a sustainable production system we have. So if you haven't seen those videos, make sure you go back and get that foundation. But what's important here is the biosphere and its fundamental makeup at the foundation of how it can operate a closed-loop manufacturing system that has existed, for millions and millions of years. How it does that is based on materials parsimony. So let me show you what I mean. This is the periodic table of the elements. You probably last time saw this when you were in your high school chemistry class, your high school physics class, or maybe in college. But what this is the material foundation of everything in the universe. As far as we know, everything in the universe is somehow, at least the universe we can see, is made up of some combination of these fundamental elements. Now, it's amazing. Out of those 88 naturally occurring elements, all of them were available to life when the biosphere was formed. But the amazing thing is, given all of those amazing possibility of those elements, the biosphere chose to focus on just 4: hydrogen, carbon, nitrogen, and oxygen, to build almost 80–90% of every living thing we see. Organic chemists call this CHON: carbon, hydrogen, oxygen, and nitrogen, and it is the foundation, it is the material fundamental foundation of life. So if you were able to look at and decompose any living object, a tree, a bush, a fox, you would find that it is made up of some combination of these elements. If you add calcium and phosphorus to the mix, you get about 98%, 99% of every living thing. That is amazing if you think about it. Now think about the diversity and the variety in nature, but it is founded on that dramatic materials parsimony. All right? So this is incredible, and it's if you were to look out the window into nature at this moment, that means everything you're looking at, from flowers to grass to trees to birds to animals, everything, all of those, imagine profusion of different types of organisms is fundamentally built out of those just 4 elements. It's absolutely incredible. Right? This is an important fundamental foundation, one that the ancient humans understood, all the way back to Aristotle, but we've sort of lost and forgot in the 20th century and now into the 21st century. So this is the materials palettes. Now when humans, industrial designers, materials engineers, and the like, materials chemists, look at this, they're excited. This is a big sandbox, and they say, hey, what can we do with iron? What can we do with cobalt? What kind of ways can we use bromium? What can we use strontium for, right? And they play with this to make and innovate new materials, new complex synthetic materials that are not natural necessarily to the biosphere. And that has been a fundamental driver of innovation. And so instead of materials parsimony, what we've gotten since the Industrial Revolution is materials I can't even say it, it's so complex. Materials proliferation, right? We're not getting materials parsimony, but proliferation of constant new chemicals. I've seen estimates where there's thousands of new chemicals and new materials synthesized every year. And there's 20,000, really, it's hard to get an accurate estimate on the actual number of chemicals that are available, both commercially or just in the world, because they're being created and fabricated at such a high rate. So we really don't really understand necessarily the full range of this materials proliferation we're living in. So when materials engineers look at the periodic table and look at the fact that the biosphere chose just 4 out of those 88 plus occurring natural elements to innovate off of, they say, why would the biosphere waste all the opportunities of those other materials? And the reason is that is the fundamental foundation of a successful closed loop production system. And that materials parsimony that's built into the biosphere, it's very important to recognize it has not in any way inhibited the ability of the biosphere to innovate beyond ways even imaginable for human beings. I mean, if you look at the millions of different species and the million different varieties of materials and things that the biosphere has created, slug slime, for example, or abalone nacre, a high-performance ceramic that's better than any of ours, or high-performance supercomputers that you can carry around in your head and work off a watt or so or 100 watts of energy. I mean, materials parsimony has not inhibited the ability of the biosphere to innovate and create a profusion of species that have been able to infiltrate and establish a habitat in every possible ecosystem niche in the planet. Right? So this materials parsimony is really, really important. It goes against the grain of the way we think about innovation, and we'll take a look at the consequences of human material proliferation in our next video. All right, so stay tuned.